The last class we talked about this. In a murder mystery, the detective suspects that someone has slipped arsenic into Professor Plum's nightly tot of scotch. How can we determine how much arsenic is in the whiskey? Well, that's not too hard because it's not a huge container. You take the small amount, and they explain that, but they separate it and find out how much of the chemicals in it. So that it's not too bad when it's small amounts, but when you think about a lake and 6 times 10 to the 11th, that's 11 zeros. So that's a lot of water. And if we think it was polluted with arsenic, in order to find the amount, we can't separate all the chemical from the lake. It's just too large. And that's when we had talked about before, taking parts of it. There's no way to drain the entire lake and separate it. Instead, direct measurement, and that would be an inference. So we'll take a bunch of different measurements and take averages, and that will imply it onto the whole lake. So we'll take samples, and then from those samples, we'll say there's probably this much in the entire lake. So you're making an inference when you take a small part of it and then you apply it onto the whole. When they were saying the percentage of Americans that had COVID, they didn't test every single one. They took certain areas and tested those groups in different areas of the country and then applied it to everybody. And so you're making that's what an inference means. You're taking your sample and applying it to the whole population. An inference is the process by which we learn more about some variable that we cannot access directly. The subject of inference by taking into account the information of some evidence. So what that means is, like, our subject, in this case, it was the entire lake, by taking a sample, or probably several different samples in different areas, we can imply it onto the whole lake. The COVID, by taking certain groups all over the US, we can imply it onto the entire population. Any questions on that? In our example, the subject is the arsenic in the lake. The evidence is the set of results, however many individual samples we got. Before we consider examples where the subject of inference is a numerical value, we'll look at easier sort of example where the subject of inference is an event H that may or may not happen. Does the patient have cancer? Is the well water contaminated? Did the defendant commit the crime? The need for inference arises because we cannot directly state whether it occurred or not. What we can do is carry out a test. A test is another event E, and we can observe, and which we have reason to believe will yield the evidence. So there's different kinds of tests. There's the COVID test would be one, the arsenic test, and then you see if it tests positive or negative. So there's 4 possible scenarios. I guess we'll use the arsenic in the lake since we had that problem. This would be And so if we're testing a sample, here is your test, positive and negative, and you always want your test to go across, because then when we're finding different rates, it's better. And then this is, it tested that there was arson and the water actually does have it. That's a true positive. So notice going across, the test is positive, this is positive, this is positive. So the positive here means the test was positive. The true or false is if the test was right or wrong. So if it tests positive that there's arsenic in the lake, and there actually is arsenic in the lake, then it's true positive. If it tests positive but there's not arsenic in the lake, that's a false positive. So the positives, this first one says, test says arsenic, and it's right. There is arsenic in the lake. A false positive is the test says there's arsenic, but it's wrong. So these two cases, the test said it was positive. This one was right, this one was wrong. And we use this for a lot of tests to see how accurate they are. They did these for all the different COVID tests to see which ones were more accurate but still fast. So the second part says it tests even pregnancy tests use these. So this one's testing negative. It's saying there isn't arsenic. So if it tests negative, but there is arsenic in the lake, then it's false. So both these bottom rows, they tested negative. This one was wrong. This one was right. So a true negative means the test says there's no arsenic, and it's correct, there is none. The last one, the test says no arsenic. But it's wrong, there is arsenic. Any questions on those? Always make your test go across. And you're positive on top and you're negative on the bottom, and then these will always be in the same position as long as your test is going across. And I'm not sure why I copied these, but we wrote them here. A false positive error is one in which the test returns positive answer when the real answer is no. Positive is the test, so it tests positive. This says it's wrong. This says the test was negative and it was wrong. Any questions? So these are a few to check. Is each a false positive or a false negative? Your computer rejects a file for being malware when it is actually safe. So your computer rejects it when it's actually safe. The computer rejecting it is saying it's positive that there's malware, but there wasn't. So that, I think that would be a false positive. Computer rejects it, so it thinks that there is that it's unsafe, but it's safe. So this would be a false positive. Your computer determines it's safe, so that would be when actually it has a virus. If the computer determines it's safe, it doesn't have malware. I guess it depends on which way you think of it. Is the having malware a positive? Because it would test positive for malware. This one would test negative for malware because it would not have it when actually it did. So this is a confusing one to enter. But how I would think of it is that the computer said there is no malware. So it would be negative. It's not there, it's negative, but it was wrong, so it's false. This one was it tested positive for having malware when it was actually safe. So that's a false positive. This one, the test says negative, so we know it's a negative, but it's wrong. She does have it. Makes it a false negative. Any questions? This one, the fire alarm goes off. So they're testing it and there's a positive that there's a fire because it went off, but there is no fire. So this would be a false positive. The carbon monoxide detector does not go off. So negative for carbon dioxide when there is. So this is a false negative. And last one, a student tests positive. So they're telling us they're testing positive for hepatitis C when they don't have it. So that would be a false positive. Any questions on those? Positive. After this section, in where the sections are, the notes, I added this. It's working with contingency tables and the true positives and then seeing how they actually run the test. So it is there, it's just the next link. And these were studies from a book that I have. But the dean at a fancy private high school is very worried. She suspects that about 20% of her 1,000 students on campus are using drugs. She has asked all of the parents to administer a home drug test to their children. Since it's a private school, she can require them to do it. She has read on the web that some drug testing methods believed to produce reliable and accurate results. Many of us overlook the cases of false positive and draw conclusions on suspects before confirming the results. But researchers from Boston University have found that drug tests may produce false positives 10% of the time and false negatives in 15% of the cases. Build a contingency table for the drug screening scenario. Now, when you're looking at these numerically, this is always your total. And she said she had 1,000 students. And then going down would be students that use drugs, students that don't use it. Going across is your test. So this would be the total that tested positive. And going across here would be the total that tested negative. Now, when you're using a false positive or a true positive rate, it's with a given part. So false positive means I tested positive, but it was wrong. I don't use drugs. So remember, here's where our false positive is. And it said false positive 10%. When it's finding a false positive rate, that percentage is from the students that don't use drugs. It's assuming of the ones that don't use drugs, 10% of them tested positive. So you use the total here, not here. Anytime you're given a rate, use the percent below it. Let's find the values below so we can find that 10%. Building a contingency table, assume the dean is correct. 20% of the students are using drugs. So if we have 1,000 students, 20% of them are using drugs. 20% of 1,000 means to multiply. So 20% times 1,000, 200 of the students are using drugs. If her hunch is correct. So we're going to assume she's right. Any questions? Now going across, it needs to add up to 1,000. So if 200 use drugs, how many don't use drugs? 800, because the two together need to add up to 1,000. Any questions so far? So we know the false positive was 10%. To find out how many, you take 10% of the total below it. So 10% of 880. Adding down. Remember, it has to add up to the total. So if I take that 800 minus the 80, I get 720. Any questions so far? False negative is 15%. Well, false negative, first of all, negative is this row. And if it's wrong, so what that means is the student tested negative, but they used drugs. So that's right here. And it's 15%. Of the ones that use drugs. So these false negatives, you're only using the value below, not the total. Any questions on that? Now to get the totals for test positive and test negative, just go across. 170 and 80 is 250. 720 and 30 is 750. Adding down, double check, they add up to 1,000. Any questions on that? Any questions? So we want to see how many students are drug users. Now, you want to be careful if they're asking for probability or how many. In this case, we're looking for how many are drug users. So we look where the students use drugs, go to the total, 200. How many drug users tested positive? Well, this column is the drug users. The test positive is this one here. They tested positive and they used drugs, 170. Now the given ones, if a student tested positive for drugs, so that would be only the column where they tested positive. The student tested positive for drugs, what's the probability he really is on drugs? If he tested positive, that narrows, it takes out the ones who tested negative because we know something about it. So it would be 170 out of the 250. It can be written as a decimal or a percent also. If a student tested negative, so then that's this row. What is the probability he is really drug-free? So he tested negative, but he is drug-free. 72 out of 750. 720, sorry. I'm gonna write the rate. This is positive. Oh, I guess we don't need to. False positives were given up here. Any questions on the probabilities? What would you think about the test if you were in the false positive group? So think about what the false positive would be. You tested positive, but it was wrong. False positives. You tested positive, but you don't use drugs. Think about it. You tested positive, they're already assuming you use drugs. They don't always think about the test could be wrong. And so this would be something I would ask you, maybe on a test or next week's homework. But the false positive means the test says you use drugs when you don't. That would be terrible. And hopefully they don't take too long to get it retested. At the high school where my kids go, they do random testing. Well, first everybody who plays a sport has to be tested. And so if it tested that you were on drugs even though you weren't, it could be 3 weeks before you get another test set up. And during that time, you can't play your sport. Or if you drive to school, you can't drive to school until you get another test. And so that could really mess things up for you, especially if you're a senior in sports and you don't get to play for 3 weeks. That makes a big difference when you're trying to get a scholarship for college, especially if it's wrong. If it's correct, then it's their own fault. But there is that 10% that out of 1,080 people, and if you're talking about sports, 80 of them, that's a lot. Any questions on that? Okay. If you think of this one, what would you think about a false negative? So that means you tested negative for drugs, but it was wrong. You used drugs. That's here. These 30 people, the test was negative, but they actually used drugs. They're going to be pretty happy. They got away with it this time. Hopefully their name doesn't get picked in the random drawings. So a lot of these, they to play a sport or to drive to the school, they test everybody. But then every so many weeks, they pick maybe 10 or 20 students randomly. And you can get picked more than once. My niece got picked 3 times in a 2-month span. So it's just a random who's unlucky, I guess. But any questions on that? Everyone's okay with what they mean? Okay. Do one more. This one's kind of interesting. There's actually court cases where people are getting criminals lighter sentences or into a rehabilitation place instead of jail, just by this study that was done. An article headlined, "Happy Halloween, kids who eat candy every day will grow up to be violent criminals." In the October 2nd, 2009 Daily Finance begins. Quick, hide the candy jar. Feeding your child candy every day could help turn Junior into a violent criminal, according to a large study in Britain, which found that 69% of participants who committed violence by the time they were 38 had eaten sweets and chocolate nearly every day. For 4 decades, researchers from Cardiff University in Wales have studied nearly 17,500 participants born in 1970, they learned that 10-year-olds who munched on sweets daily were significantly more likely to have convicted a violent crime by 34 than those who enjoyed a candy occasionally. According to the study published in the October British Journal of Psychiatry. But not all childhood chocoholics had gotten into serious trouble when they were older. Of the participants who had not turned out violent as adults, 42% had eaten sweets. So there's a study for 4 decades, 17,500 participants. Now, I went back and read again, and it didn't tell me how many were violent criminals and how many were not. But I thought if you were going to do this extensive a study, then you'd probably take half and half, as close to half and half as you could. And so I'm assuming that it's half. I could not find where they said anything about how many were violent and how many were not. But if you're going to do this extensive a study, I would think you would try and get half and half. So that's what we're going to assume. There's 17,500 inmates, and half of them are violent criminals and half of them are not. And then our test is they ate candy every day or they ate it occasionally. So if we take this and divide it by 2, that means there was 8,750 who are violent and 8,750 who are not. Any questions on that part? Now we need to find these boxes. This was our, here it is, 69. Here's one. 69% of the participants who committed violence, so that's this column, 69% that committed violence had eaten sweets every day. So that's here. They ate candy every day and they're violent. 69%. And notice it says 69% of those who committed violence. So that's of the 8,750. Because it's 69% of the violent ones, not of all of them. Now this comes out a decimal, and I'm just going to keep the decimal. Even though you can't have half of a person, I'm going to keep the decimal. You could round it. Any questions so far? So this is 8,750 is our total. To find those who were violent but didn't have candy all the time, you just subtract them. Because remember, this plus this has to equal this. So if I subtract them, I get 2712.5. Any questions on that? Another percent right here. Of the participants who hadn't turned out violent, so that's this column, not all of them, 42% had eaten sweets every day. So non-violent but ate sweets is here. It's 42% times of those who were not violent, 8,750. Any questions? If we take the 8750 minus the 3675, that will give us the amount here, which is 5075. Add across, get your totals.
I would say you might want to jump that out.
The top one, 6. And then add the 2 to make sure you come up with the 17,000. Any questions? How many violent adults ate candy? So violent adults are here. Eating candy is here, so they overlap here. $6,037.5 or 6,038. How many non-violent adults ate candy? This is non-violent. The top is ate candy. 3675. So half as many. Or double. Of those who ate candy, twice as many were violent. Any questions on that? What do you think about the study?
I think there's just criminals out there eating candy and committing crimes.
Yeah, I don't think how much candy your mom gave you when you were little is the reason that you're violent. But there are cases, because if you search this, you'll find lawyers who are getting paid enough to bring these up on cases and show. I don't know how you can prove that they ate candy when they were young, but there's court cases now. I don't know. People think of anything to get off instead of just don't commit the crime.
There's probably rappers on the crime scene.
Yeah, I could see that in their car. There's rappers everywhere. My dad used to do that. He'd be running from our soccer matches to work to soccer. And so then if you got fast food, he'd just leave all the bags in his car. So then as a joke, people would go during the game and put more empty bags in his car so that he didn't know what was the trash. So I could see that happening. But is there any questions on it? I mean, this is probably a study that should not have been done. I think this is a good study because then you know how accurate the test is, but you also know just because they tested positive and maybe you know they're a really good kid and they're always there and you don't think they're using drugs, well then you can find another test. Maybe there's tests that are more expensive and more accurate. So you don't want to do it on everyone, but you want to do it on these so that they can keep doing or playing the sports or driving to school, and not have people looking at them differently because they think they use drugs. But there's lots of cases where they use a fast one to find the majority, and then they use other ones to get the rest or help the ones who shouldn't have been tested positive. Any questions? Okay. Um,